take it anymore. Where was I? Hey guys, it's the Grouchmeister, and today we're looking at mill vices, or at least this particular mill vise. This is, of course, a cheap overseas knockoff. It's definitely not a Kurt by any means. And then I noticed my vise was feeling kind of crappy. The lead screw was loose and wobbling around, and I was kind of wondering why, so I figured it needed cleaning. I thought I was crunching some chips or something. So I get it apart, and I noticed the thrust bearing is borked. Now, when your lead screw's in place and you're cranking down on it, of course it's going to push the lead screw back away from your work, because that's what's providing the pressure. And there is this ball thrust bearing here, and these are the two races, and you got a little cage of balls, or a set of balls that just sit in between, you know, like the cheapest thing they could find. And this is where the problem lies. I don't know if you can see this. Let's see if we can zoom in and get everything to stay there. Okay, let's make sure now. Probably kind of hard to see in this light, but you see these cracks? This whole race is barely held together by the plating, if there's any on here, because this race is dished out. There you go. See those facets on the back side of that? That's because it's been squashed. This is the surviving good one, and it's alright. There's no facets in it, it's just some of the machining, and if there is, it's a little bit. But either way, actually it looks like it is cracked. Son of a gun. Either way, I'm ordering another one. So what caused that? Well, very crappy machining and a really poor choice. So one piece of the race fits in this housing here, and then the balls, and then the other race, and then it fits together inside of here. So you'll probably notice right away, look at that shoulder. That is smaller diameter than the center line of the balls on the race. So over time, when I've been squishing it down, that's been bending over the race and breaking it, because somebody couldn't be bothered to put enough metal on here to give a full backing behind the bearing. Talk about some stupid shit. Yeah, they didn't bother to clean up that bore either. So that's what I'm going to be doing. I'm going to reverse the races around just to get me through until another bearing shows up. But anyway, I thought while I had this apart, we'd look inside the mill vise. Now, a lot of you guys already know this, but for some of you guys, you know, armchair guys who just want to see what's going on, or somebody getting into this stuff, would want to know what makes a mill vise a mill vise. Well, here's the key to it, really. This is the shuttle. I don't know if that's what it's called, but that's what I'm calling it. And the idea behind the vise is when you crank it down and slide it into your part, is that the way it goes? Yeah. This will be bolted on this side. Well, yeah, that's the fixed end, right? So you're clamping in your part. Now, what keeps the jaws from flopping around? Well, it needs a mechanism that will clamp this this jaw down onto the bed, or onto the ways, or whatever this may be, and keep that nice and tight. So, because if you'll notice, it's underdriven. The screw is underneath, way underneath the jaw. So what you think would happen is you tighten up the jaw, and because the pressure is being placed from underneath, it's going to make this rise up. So there needs to be a mechanism to counter that. Otherwise, every time you tighten down, your pieces are going to cock. And, you know, that's not good. So this is where the shuttle comes in. You've got an angled indentation here inside the jaw, and the shuttle has a matching angle piece And there's this crappy little half moon bearing here. I ain't gonna put it in place, it'll fall out on me. But what happens is, this is held loosely with this little keeper screw here, so when you retract the vise, the shuttle brings back the jaw. But when you clamp it down, it rides in that groove and pulls the jaw down. I'm probably not be able to show it that way, but I'll throw a cheesy graphic up that will illustrate what that is doing. So either way, I'm out of business until I get this vise working again. So my first order of business is to build up this area here and give me a full backing on the bearing. And also because you can tell this was done intentionally, because they only machined off enough metal out of the shuttle to cover that small amount of shoulder. So this is going to have to be taken back, and this has to be built up and cleaned up. And while I'm at it, I might as well clean it up, get rid of all this horrible flashing that's on this casting here. Yeah, that's just... Here's a good question for y'all, for you seasoned guys with the better stuff. Does the good American made stuff, is it just painted, cast, you know, and it's still square? Or is it like the overseas stuff where they take the horrendous castings and they flatten out with Bondo and then put paint on? That's what I'm finding out. My machine's got Bondo all over it. My heavier tools got Bondo on it. It really makes me afraid to buy a rotary table. So, I'm going to fix all this up. I'm going to throw this on the vise, get some welding, and I'll come back and try to machine all this and make it work again.
While we're waiting for me to weld up that screw, let's take a closer look at what makes a mill vise tick. Here's a crude drawing of my import model. I call her Vicky. Peeling away the outside, we see... Okay, maybe that was a bit sudden, and I didn't tell her we have company. While Vicky composes herself, we can look at what's not a mill vise. This is Debbie. Debbie is commonly known as a drill vise. While Harbor Freight may refer to this as a mill or machinist vise, they are wrong. These simple vices are for holding work in a drill press. They are also fine for sawing, tapping, filing, and so on. The base and the fixed jaw are one piece, and the moving jaw is held onto the slide with a retaining plate screwed on underneath. The moving jaw is pushed by a lead screw that is threaded through the base, and it moves with the jaw. The lead screw is rounded on the end and fits into a matching socket on the jaw, and this acts as a thrust bearing and allows the jaw to tilt and swivel a few degrees to allow it to clamp onto odd-shaped or uneven parts. The fit and finish is much looser than a mill vise, and they just can't hold parts rigid enough or accurate enough for precision work. Now let's get back to Vicky. Look at those broad shoulders, the wide hips, and big jaws. While Debbie is good for the occasional fling sharpening your mower blade, this is the gal you want helping you to create the offspring that you will send out into the world. The base is usually made of cast iron because it's stiffer than steel, yet able to absorb shocks well, like when you do fly cutting. The moving jaw is connected to a shuttle, and the shuttle transfers the force from the lead screw up to a pivot bearing. The lead screw is fixed to the base with thrust bearings or washers. The fixed jaw is keyed to the base and bolted on from underneath. This key stops the jaw from putting shear stress on the bolts and keeps it aligned with the base. This is the area that failed on my vise, and if you have an import model, I urge you to check this area for weakness or defects. You can see here that the shoulder is too small to properly support the thrust bearing, and only the outer portion of this race has been supporting all of the clamping pressure from the lead screw. It was destined for failure, and I'm really surprised it lasted this long. I guess I'm just a wuss when it comes to handling Vicky. While a custom thick washer may suffice, that would just be another item to get lost when I have it apart for cleaning. I chose rather to build up the shoulder with a MIG welder and machine it to size slightly larger than the bearing. This should fix the problem and put this vise back into active duty. Now, any moving part has to have some slop or play in it or it wouldn't be able to move, right? Notice that the angled portion of the shuttle rides in a matching angled pocket in the jaw. This is the magic in a mill vise. As the lead screw is tightened against a part, the shuttle rides up on the pivot bearing. Since the shuttle has the base sandwiched between it and the jaw, the effect is to pull down and clamp the jaw firmly onto the bedway. This, along with the large rear skirt of the jaw, removes the slop and keeps the jaw perpendicular to the base under heavy pressure. Vicky doesn't really care if you put a part in the top, bottom, or middle of the jaws. They're going to be straight. While Debbie is always going to be sloppy, Vicky is as tight as a drum and won't get bent out of shape when the pressure's on.
Okay, here's the built-up screw. Probably went a little overboard. Got carried away. Wow, looks like I warped it too much. That'll work. Got a while to go yet. This is 3770. I want to go like 31. is 32. So I'm going 1 mil over just to make sure it's got a solid shoulder to lean on in case it gets depressed and all that. Left hand tool. Snap off right there. Give it a stress riser. Come on, too bad. little jaw pressure on it. Get up against that key. And wrench it down. Okay, there you have it. Mill vise, back in business.